Okay, here we are for lesson 13 and continuing on our subject of inequalities. We're going to take a look at solving inequalities like we would do equations. So for our opening exercise, writing inequality statements, our problem is Tarek is trying to save $265.49 to buy a new tablet. Right now he has $40 and can save $38 a week from his allowance. Write and evaluate an expression to represent the amount of money saved after. We're going to do 2 weeks to start. So what that would look like is we would plug 2, since it's $38 per week, we can multiply that by 2, and he already had $40 saved up. So by using our order of operations, solving that for 2 weeks, he would have $116. So go ahead, using that same process, what would it be for 3 weeks? Well, for 3 weeks, it would be the same expression except 2 becomes 3. So that would be $40 plus $114, which is $154. So go ahead and complete the rest of the weeks in the same manner, and then continue the video when you are finished. All right, so you should have for 4, 5, all the way through 8, this is the work that you should be showing, that you are substituting the value in and coming up with an amount after each week. So when will Tarek have enough money to buy a tablet? Well, if you look at these ending values, you will notice that it is at 6 weeks and beyond. So from 6 weeks and onward, he will have enough money to buy that tablet. So write an inequality that will generalize this problem. Well, $38 times the amount of weeks plus the $40 he already had saved up has got to be greater than or equal to $265.49. And again, the W represents the number of weeks it will take to save the money. So why is it possible to have more than one solution? Well, it is possible because the minimum amount of money Tarek needs to buy the tablet is $265.49. He can save more money than that, but he cannot have less than that amount. But as more time passes, he will have saved more money. Therefore, any amount of time from 6 weeks onward will ensure that he has enough money to purchase the tablet. So the minimum amount of money Tarek needs is $265.49. And he could have more, but he certainly can't have less. So what inequality would demonstrate this? Well, it would have to be greater than or equal to, because again, he can't have less than, because then he wouldn't have enough money to buy it, but he can definitely have more than, it's just he'll have money left over. So examine each of the numerical expressions previously and write an inequality showing the actual amount of money saved compared to what is needed. Then determine if each inequality written is true or false. So for 2 weeks, he had $116. Is that greater than or equal to $265.49? Well, the answer to that is false. So go ahead and do for each one 3 weeks on up to 8 weeks and determine whether it is a true or false statement. All right, so for 3 weeks, again using greater than, because he has to have it at least $265.49 or more than that. And so $154 is not greater than $265, so again we still have false. And for the rest of the weeks, as we go through and keep comparing, once we get to 6 weeks, $268 is greater than or equal to $265.49, so that is a true statement. And also for 7 weeks is a true statement, and 8 weeks is a true statement. So how can this problem be generalized? Well, instead of asking what amount of money was saved after a specific amount of time, the question can be asked, how long will it take Tarek to save enough money to buy the tablet? Well, write an inequality that would generalize this problem for money being saved for W weeks. That means it would be 38 times W for the weeks plus 40. It's got to be greater than or equal to $265.49. So interpret the meaning of 38 in the inequality. Well, 38 represents the amount of money saved for each week. As the weeks increase, the amount of money increases. The $40 was the initial amount of money saved, not the amount saved every week. All right, so let's take a look at example 1. The sum of two consecutive odd integers is more than negative 12. Write several true numerical inequality expressions, at least 5. So pick two numbers that when you add them together, and again they both have to be odd and they need to be right after each other, that would be more than negative 12. Go ahead and do this and then continue the video. All right, so some examples you might have come up with would be 5 plus 7, because again 5 is odd, 7 is the next odd number. 3 and 5, 1 and 3, negative 1 and 1, or negative 3 plus negative 1. And you can come up with several others. So the sum of two consecutive odd integers is more than negative 12. What is the smallest value that will make this true? Well, for part A, we want to write an inequality that can be used to find the smallest value that will make the statement true. So to ensure that the integers will be odd and not even, the first odd integer is 1 unit greater or less than an even integer. So if x is our integer, then 2x, or 2 times x, would ensure an even integer, and 2x plus 1 would be an odd integer since it is 1 unit greater than an even integer. So if we picked x as our integer, then to ensure that it is going to be odd, it needs to be 2 times x plus 1, which means the next odd integer would be 2x plus 3. So if we want an odd integer and the next odd integer to be greater than negative 12, we would take these two expressions, the 2x plus 1 and the 2x plus 3, and make that greater than negative 12. So for part B, using if-then moves to solve the inequality written in part A, identify where the zeros and ones were made using the if-then moves. So simplifying this, we get 4x plus 4 is greater than a negative 12. Well, that means we're going to subtract 4 from both sides, because again, if a is greater than b, then a minus 4 is going to be greater than b minus 4. And our result is 4x plus 0 is greater than negative 16. So the next part then would be to either divide by 4 or multiply by 1/4. Because again, if a is greater than b, then a times 1/4 is still going to be greater than b times 1/4. So we end up with x is greater than negative 4, because 1/4 times 4 is 1. So the values that will make this true are all consecutive odd integers that are negative 3 and larger. So what is the difference between consecutive integers and consecutive even or odd integers? Consecutive odd or even integers increase or decrease by 2 units compared to consecutive integers that increase by 1 unit. So what inequality symbol represents is more than, and why? Well, it would be the greater than sign, because a number that is more than another number is bigger than the original number. So what is a solution set of an inequality? While a solution set contains more than one number, that makes the inequality a true statement. So is negative 3 a solution? Well, yes, because when the value of negative 3 is substituted into the inequality, the resulting statement is true. Could negative 4 be a solution? Well, substituting negative 4 results in a true statement. However, the solution must be an odd integer, and negative 4 is not an odd integer. Therefore, negative 4 is not a solution. So we have found that negative 3 is a solution to the problem where negative 4 and negative 5 are not. What is meant by the minimum value? Have we found the minimum value? Explain. Well, the minimum value is the smallest odd integer that makes the statement true. Since negative 3 is a solution to the problem, and it is an odd integer, it is the minimum value. All odd integers smaller than negative 5, such as negative 7, negative 9, etc., are not solutions. Negative 3 is a solution, but it is greater than negative 5. So how is solving an inequality similar to solving an equation, and how is it different? Well, solving an equation and inequality are similar in the sequencing of steps taken to solve for the variable. The same if-then moves are used to solve for the variable. However, they are different because in an equation you get one solution, but in an inequality there are an infinite number of solutions. So what are the steps to solving the inequality algebraically? Well, again, first we collect like terms on each side of the inequality. To isolate the variable, we subtract 4 from both sides. Subtracting a value 4 from each side of the inequality does not change the solution of the inequality, and that we discovered in previous lessons. Continuing to isolate the variable by multiplying both sides by 1/4, multiplying a positive value 1/4 to both sides of the inequality does not change the solution of the inequality. Remember, what reversed our inequality signs was multiplying or dividing by a negative number. Alright, so for exercise 1 and 2, go ahead and complete the exercises and check your answers when you are done. Alright, so let's take a look at exercises 1 and 2. Here are the answers to 1. Go ahead and compare your answers to the answers provided here. If there's something that doesn't make sense or that you don't understand, please make a note of it and bring it to class. And here is the answer to exercise 2. All right, so to wrap up, how do you know when you need to use an inequality instead of an equation to model a given situation? Is it possible for an inequality to have exactly one solution, exactly two solutions? Why or why not? All right, we'll talk to you in class.